Hey everybody, here we have this motherboard that was pulled from eMachines, plugged up and running. But the thing is, it's not actually running. It's just spinning the fans. While some people may mistake this board for being fried by the Bestech 250-watt power supply, this particular motherboard was from a different kind of system. This motherboard was from a system with the Bestech HDX 312E power supply, which is built on the standby circuit of the 12Z, which doesn't use a 2-transistor design, which fries motherboards. This motherboard failed due to a different reason. This motherboard has the nVidia GeForce 6100 series graphics chipset on it, and this chip is highly known to overheat and back off from the board. The solder joints will break and end up losing their contact from the motherboard. So you end up getting this. What's really surprising about this motherboard though is 2 or 3 times over the years that I've had it, it actually posted and came to life. There was even one time where I hooked a hard drive up that had an operating system on it and was able to run the operating system just fine. So we're going to try and experiment with this motherboard. We're going to attempt to reflow the solder on the north bridge of this main board to see if we can get it to work again. The first steps you want to do preparing your motherboard are to remove the CPU, the north bridge heatsink, and your CMOS battery. After that, you want to make sure you can get the north bridge chip as clean as possible. I mean, there's still some old thermal gunk left on the sides, but you can see the chip die is fairly clean. I also went ahead and removed the CPU bracket from the board as well. Okay, now I'm outside behind the garage, as you can see the tools and everything. Before I begin, let me explain a little more about what causes this to happen with these chips backing off from the main board. This is mainly caused by a lack of adequate cooling. On this particular motherboard, they use a very tiny heatsink with the pink bubblegum style thermal paste that doesn't do very well at transferring heat from the chip to the heatsink. The heatsink you saw earlier in this video wasn't the original heatsink on this board. The one that was on this board was a very, very tiny black heatsink. And this problem not only occurs with this particular board, but also occurs with an MSI board that's used commonly in eMachines. It also occurs often with some HP laptops, along with Xbox 360s and PlayStation 3s. Similar chips, but same issue. They overheat, and the solder breaks loose from the board. This is lead-free solder for you. Anyways, what I'm going to do here is I'm going to use the heat gun. I'm going to start around the back side of this board, heat this up on a low setting. Then I'm going to flip this main board over to the other side and then heat the top side of the chip. What you see here is a piece of tinfoil that I crammed around the chip. The purpose of this is to divert heat away from other components such as the electrolytic capacitors. They don't like heat. So anyways, let's get started. Okay, the heat gun I'm using in this video is a Milwaukee 1200 watt heat gun. Looked online, you can usually get a Wagner 1000 watt heat gun from Walmart for like 20 something bucks, so not too expensive. Anyways, like I said, I'm going to pre-treat the bottom of the board on low setting to get it warmed up, and I'm going to flip the board over and then go to the high setting and carefully heat up the chipset. What you'll do is going to sweep a motion across the board in the area that you're going to reflow. About a minute or so. which also doesn't hurt to go over the South Bridge area too. Okay. Board is a little bit warm, but I can still handle it though. Flip it over on this side. I'm actually going to flip it around so you can see it on camera. I'm trying to be sure if this thing stays off the ground, off the board, off the surface. I mean, not the motherboard, but anyways. This is a spot we're going to be very careful. Because like I said, we have electrolytic capacitors which are rated for 105 degrees Celsius max temperature. So now I'm going to run this on high, but keep my distance to help be sure I don't overheat these capacitors. And if you're ever doing this to your motherboard, don't have your heat gun pointing directly at these capacitors because they will not like it at all. We'll do this for about 3 or 4 minutes or so. Like I say, the purpose of the tin foil, the aluminum foil, is to divert heat from sensitive components. Because we're trying to get the North Bridge as hot as we can, but not overheat the electrolytic capacitors. Will melt the PCI Express connectors on the board, or the ATX 12 connector on the board, or the memory slots on the board, or the CPU connection on the board. And keep in mind, this board will be very, very hot. So don't try to handle it after going through this step. The board is so hot I can smell it. I can smell the dust on the board. What this step does is it melts the lead-free solder and helps rejoin it with the main board. Alrighty. Next step will be to turn the heat gun down to low setting for another minute to help start the cool down process. So our time is going on 7 minutes 20 seconds on this clip. Do this step for a minute. This will help begin the cool down process like I stated earlier. All the capacitors still look fine. That's the biggest thing you gotta watch out for when you're reflowing a motherboard is your capacitors. So electrolytic capacitors do not like heat. Do not like excessive heat, I should say. Okay. Anyways, we'll let this motherboard cool down for about 30 minutes. Then we will plug everything back up and see how it does. Well, okay, I got everything hooked back up, and we now have us a working motherboard. Of course, I need to go in and reset the CMOS. I mean, change the settings because the CMOS has been reset. But this board is like new. Works just fine. So anyways, that's how you reflow a motherboard. And this is my first time ever doing it. And so far, everything is looking good. Had any questions or comments? Let me know.